Hey everybody, we're taking a look at page 683, question 21 from our text. We're solving a system of conics, and this first equation has two squared terms. Their signs are the same, so it's not a hyperbola. Their coefficients are different, so it's an ellipse. So I've got the equation of an ellipse meeting the equation of there's only one squared term here, so that's a parabola. Right? So there's two ways you could solve this that I see. I could solve for y and then substitute into this y whatever we get and go from there. That actually gives you a fourth degree polynomial, which you can solve by factoring using either u substitution, all right, which you might recall from back in the day, or you can actually GCF the whole problem and solve it that way. So you'd end up with multiple solutions there. The other way we could do this is elimination, and that's what I'm going to do here. I'm going to eliminate the x squareds, and then I'll have a quadratic in terms of y. So let's do that. So I'm going to multiply the second equation by -1. Seems like a good idea. So I'll have negative x squared minus y plus 3 equals 0. And I'm going to add that to my first equation. All right, so x squared and negative x squared is 0. 4y squared and no y squared is 4y squared. No y and negative y is negative y. Blank and 3 combined to be 3. And 36 and 0, 36 and that 0, sorry, is 36. So what I've got here is a quadratic written in terms of y. And we've been doing completing the square, so let's roll with it. Let's see, 33. I'm going to have to factor out the leading term, 4 right there. So I'll have 4 parentheses y squared minus a quarter y, right? Because 4 times a quarter is 1, right? Equals 33. And I can divide both sides by 4 here, or I can find my new c term. I'll divide both sides by 4, just what the heck, doesn't matter though. That's a choose your own adventure on that step. Y squared minus a quarter y blank equals 33/4 blank. All right, so let's keep going. Find my new c term. Negative a quarter divided by 2 all squared is going to be negative an eighth squared, which is positive 1/64. So add 1/64 here. I'll add 1/64 there. To find a common denominator, multiply by 16 and 16, it looks like, if I'm not mistaken. I can fast factor this side, so that's going to be what all squared? That'd be a y and a minus an eighth. Okay? 33 times 16. This might be where you were getting a large number, Christiana, maybe. I got 528/64 plus 1/64. No, maybe not. And when I add those, I get 529/64. Right? So then I can root both sides. I know I'm cruising through this. I'm not expecting you to necessarily write this down. Just absorb this, perhaps. So y minus an eighth is equal to plus or minus the square root of 529. Is there a perfect square that goes into that? 529 divided by, it's not even, so it's none of the even ones. 25, no. 9, no. I don't know. I can't think of any right now. 121 doesn't go anywhere or anything, right? No. Well, that's fine. I'll just leave it as the square root of 529 over, and square root of 64 is 8. And then I would add an eighth to both sides. and I get y equals 1/8 plus or minus the square root of 529/8. So those are my two possible y coordinates for this point, and I'm guessing that's about negative 2.8. Let's verify. Square root of 529. Oh, it's 23. What? Why didn't I even try that? Oh, that's embarrassing. I was like, is this a perfect square? Is there a perfect square that goes into it? That's so funny. It was a perfect square. So 1/8 plus or minus 23/8. So I get y equals 24/8. Right? Wait a minute. Yeah, which is 3. Or y equals 1 minus 23, so negative 22/8, which reduces to negative 11/4, which is, why am I blanking? Negative 2.75? 2.75 is exact. But you're right, I think the directions on this particular problem does say round to the 10th or whatever anyway. So there we go. So there's my 3 and my negative 2.8. Okay, that's funny. Square root of 529. Classic. So now that I found my two y's, I want to find my x's. I'd probably plug them into the x squared plus y minus 3 equals 0. X squared plus y minus 3 equals 0. And I'm going to plug in each of these. So one of them I'll plug in 3 for y. X squared plus 3 minus 3 equals 0. X squared equals 0. Root both sides, plus or minus, don't forget it. Plus or minus 0 does not make sense. It's just 0. So one of my points is 0, 3. Hooray! And then the other one, I'll have x squared plus negative 2.75, I guess, minus 3 equals 0. So that's x squared minus 5.75 equals 0. X squared equals 5.75. Root both sides, plus or minus, don't forget it. I'm cruising here. So x is equal to square root of 5.75 is 2.3979, or 2.4, we'll call it. And it's plus or minus. So we got it. And that was when I had, what, negative 2.75 and that. So that is plus or minus 2.4 and negative 2.75. So question, how many intersections did I have here? 1, 2, 3, right? Because there's 2 represented there. I could have rewritten this twice, just the positive and the negative version if I wanted to. Let me try to graph this. I'm going to try one more time using technology to graph this just because I want to be cool. Let's see, this first one, I'd have 4y squared minus x squared. No. I would have subtracted x squared from both sides. So equals negative x squared plus 36. I would divide by 4. Y squared equals negative x squared over 4 plus 36 divided by 4 is 9. And then I'd root both sides, plus or minus, don't forget it. And I'd get y equals plus or minus that. All right, negative x squared over 4 plus 9. And just because you see that minus sign on the x doesn't mean that this is going to be imaginary. As long as this term is less than 9, this square root will exist. All right, so that's fine. So that's going to be our ellipse. And for the parabola, I would get y equals negative x squared plus 3. So those are the two equations I have to graph. So let me open up this. I'm going to graph those right now. So I would have square root squirt of negative x squared divided by 4 plus 9, right? So there's 1. And let's see, is that the top half of an ellipse? Yes, it is. Hooray. Let's see, graph, and the other one's just the negative version of this. So I'll just do that to get the bottom half of the ellipse, right? And now let's get the parabola. So I'll graph negative x squared plus 3. And you can see, whoa, that's so cool, guys. That's almost like, reminds me of the Star Trek symbol somehow. Or was that a Toyota or a Hyundai symbol? I don't know. Acura maybe? Sure, it's something. It's something, but there we go. And I also could have graphed that using my regular old quadratic technique stuff. So here's the point 0.3. Here's the point, I'm guessing, negative 2.4, negative 2.75, and positive 2.4, down 2.75 right there. So what do you know? And you can imagine that if this parabola was shifted up a little bit more, I could have had 4 intersections, right, like that. So there we go. Thanks for watching, internet friends. Not bad. So there are multiple ways to do this problem, though. Just want to point that out. Bye-bye.